about biodiversity and ecosystem responses to climate change. I recommend to the speakers to keep the time because we have a very bucket program. And we will start with Professor Alberto Basset, who is giving a talk about the ITINERIS project, e-services for deepening current understanding of biodiversity and ecosystem responses to climate change. Professor Basset, the floor is yours.
Thank you so much, Cristina. Okay, so I'm going to, good afternoon to all of you. I'm going to present you a couple of initiatives that are running in Italy in the next 3 years, which for Italy are impressive. So they're unexpected and I would say incredible. That is with two huge initiatives from our ministry. One is ITINERIS, which is in the title of this presentation, which is a project that is dealing with infrastructure. And the second one is reported here. You don't see, but it's the National Center for National Biodiversity Future Center, which is a new center for biodiversity that has been launched by our Ministry for Education and Research, for University Research, June last year. So there are two opportunities for the scientific community in Italy and two opportunities for the research infrastructure, since directly and indirectly LifeWatch is involved in both of them, as well as ICOS, LTR, DISCO. Most of the environmental research infrastructure are in the game. But before entering in detail in the discussion in the game, well, then this initiative and this project are expected to give results. And are expected to give results that are relevant for the country, in terms not only of knowledge, but on the conservation, the mitigation, and the preparing the field for adaptation to climate change in the longer period. And then the challenge that we have to conserve and maintain biodiversity and manage biodiversity in a biosphere that is changing, so in the context of the global niche that is changing is surely challenging. And there are a lot of things that we know, but there are a lot of things that actually not only we don't know, but I think it's really rather difficult to be addressed unless we manage to build theory on that and to have quite a strong theory. So, for example, basically we know a lot of the different mechanisms of biodiversity organization, competitive coexistence that exist, and there is now a modern community ecology, or modern coexistent, competitive coexistence theory that is focusing in dealing with both niche and what is then is described in a very simple way with all factors that affect fitness, or then we can have including some sort of body side that is related. But to what extent climate change is going to affect fitness at the within population level, so maintaining or actually modifying the phenotypic arrangement within population, where there is affecting fitness among population, altering somewhere the competitive relationship among species is really complex in order to address. And that is something that such a huge project some way need to address, even because while we have clear what can happen in terms of species distribution change, of metabolic rate change, and sort of life cycle changes, what is less clear to us basically is how much all this changing are then having an impact on human welfare, and to what extent the ecological response to climate change are impacting our society and our economy. When we think to climate change, we are considering to temperature, sea level rise, precipitation. Of course, there's the tragedy that we have in Italy these days for Emilia-Romagna is one of the outcomes, which is also related to unmanaged biodiversity and ecosystem health in the northern Italy. But it's also related clearly to the direct effect of climate change. But then what is the indirect effect? So those are related through the influence that climate change is having on every single individual on this planet. Is much less predictable in terms of individual species or individual population. But it is expected to have an impact which is absolutely relevant. Some estimation in terms of the changes in physiological rates are estimating that there is going to be a 20% increase in the rate of all the physiological rates. And some estimation are highlighting a loss in continental river basin of 15% of net primary productivity at 2100. And then all these kind of things are affecting in a very deep way our potential developmental sustainability. And if we consider the sustainability of development without considering how the system is going to change, probably we are not going to get anything in the next 50 years. So it is something which we need to be involved in. And there are some questions that I'm going to pose then after. But then, one thing that we can actually see is that, for example, in a basin like the Adriatic Basin, which is absolutely a closed basin, then we could expect that the global warming is affecting quite in a strong way the standing biomass that we can build as a scenario in the Adriatic for the future 50 to 200 years. Then one way Italy is trying to address this point is with two projects. One project is ITINERIS. And ITINERIS is a project that is funded in terms of research infrastructure and is involving almost all the research infrastructure on the environment that we have in Italy. So there are 7 partners, but 22 European research infrastructure, basically all the ESPRI landmarks that are in the environment, and also some of the landmark that is not in the environment as domain, but is in art and food, and some that are also in the area of physics. Then there are a number of ESPRI projects and other number of projects and a few Italian research infrastructure. The fund, the budget is 155 million euro. Most of the budget is involved is to be spent in infrastructure that are going to be physical and virtual. At the moment, we have already hired 195 fixed-term personnel, and that is the project is going to last in 2025, on the 31st of October 2025. Well, there's a counterpart. So ITINERIS are the infrastructure. The National Biodiversity Future Center is the scientific research for basically understanding a bit more of biodiversity, monitoring, conserving, managing, and then exploiting. So one of the, we were all impressed about the action of our ministry, because in Italy they have launched 5 national centers with 1.6 billion euro, and one of these is on the biodiversity, full stop, biodiversity. And then it's not only because we like to study biodiversity, and then because I'm puzzling since 30 years ago a bit more on how diversity can be maintained at the intra-population or among species level, but because they have realized that if we have a natural resource that is valuable in Italy, is the biological diversity. And biological diversity has to be preserved and used for business. And that is what they want to do with this national center, that is assess, monitor, preserve, recover marine, terrestrial and urban biodiversity, and then give value as a central element for the sustainability of the socio-economic development. So it is an idea of deepening understanding in order to be able to manage it. And the organization, well, the budget is 320 million. We have 1,300 researchers, and it is organized with marine, terrestrial, including freshwater and transitional and urban conditions. So let me go very fast because they say we have 5 minutes. So ITINERIS want to build an app for the research infrastructure in Italy, and then is actually harmonizing the different research infrastructure, harmonizing the data, represent the single point of access to not only e-infrastructure but to physical infrastructure, so and to merge the physical activity in the infrastructure, so transnational access to the virtual transnational access. The structure is structured with a number of work packages, basically, and what is important to us and to the discussion of today is that there are 5 work packages that are thematic, and it's the work packages that are dealing with the biosphere, hydrosphere, atmosphere, and geosphere. Probably it's not disorder, but it's at the core. And then one transversal work package that is dealing with virtual research environment. Because there are virtual research environment of interest not only for LifeWatch, but also for the other research infrastructure. And then there are basically 10 virtual research environments, because one virtual research environment, that is the ERIC, is of interest of LifeWatch and is in the biosphere work package, and is meaning to address phytoplankton guild organization and ecological responses to climate change. Then we have a virtual research environment on the critical zone services, a virtual research environment on crop, plant and pest theory, addressing crop production, plant phenology, pest and so on, and a virtual research environment on the essential variables. And then another that is of strict interest for LifeWatch is going to be a virtual research environment on aquatic biomass services that address the response of aquatic ecosystem, in particular of the standing biomass to climate change and to climate warming. And then there's a virtual research environment on the aerosol biosphere, that is basically actress. A virtual research environment on the carbon, that is related to ICOS, together with the one of climate. And then on downstream effect of environmental changes. And the virtual research environment on the isotopic information, which is really interesting, basically, to all scientists, because it's collecting in a single virtual research environment all the research with the stable isotope, going from the geological one to the physiological one to the analysis of food webs. Then in terms of what we're going to do particularly, then we're going to focus on these 2 virtual research environments. One is what we already have in LifeWatch, is the ERIC, which is already going to be restructured with now ERIC from the University of Amsterdam, and then we're going to evolve furthermore using the full integration of the LifeWatch virtual research environment services with the SERAT and now ERIC, basically enlarging what already the phytoplankton BEeS does, focusing on 2 things: the mechanism of phytoplankton guilds organization. So it's one of the challenges the plankton paradox. And then there are a number of mechanisms explaining plankton paradox, but we don't know actually how they are organized. And we don't know actually which mechanism is more relevant where. And then if you want to maintain and to protect productivity, then this question mark should find out an answer, or should find out a way to approach an answer. And the other point is that the phytoplankton metabolic response to global warming. So in terms of what we actually expect in terms of the net primary productivity in our latitude, because most probably in the northern latitude we are going to have an increase in net primary productivity. We surely could have an increase in productivity because we have less ice. But in our region it's going to be really very different. And another point that could be relevant is that what is the effect of global warming on all those kind of products that we are now obtaining from phytoplankton. How much it is going to affect, in a positive or negative way, our capacity to use these natural resources. And then dealing with the biomass, then we should try to find out an approach and a way to give answer to this question. Will overall standing biomass decrease in the next decades? How much is going to decrease? Are all the ecological domain or ecosystem types more explored, more exposed? Are there potential mitigation strategies? On which basis? I think this is going to be the most interesting point. Can we expect to have mitigation strategy on a process that is going to be directional and is going to be permanent? And then it's something that we will try to approach. Well, there of course there are experimental tests that are describing how much metabolic rate are increasing with the 0.3, 0.6, 1.2 degree. But what we are going then to try to do and to put in the virtual research environment are basically data resources and services that are coming from the data producer on the ever smaller temperature range to integrate the data from existing repository. We have already built our block of about 2,000 species where there is analysis of metabolic rate with the range of temperature. How this range of temperature is going to be related to other different components of the individual personality, in this case is with the species behavior. And then try to integrate experimental modeling data of individual personality trait induced fitness across the temperature gradient, because that is one is going to be a possible internal mitigation of climate change. There is a huge difference in the individual personality traits of metabolic rate and behavior for most species, surely for most invertebrate and a lot of fish species, probably much less for vertebrates, for birds and mammals. And then there are already evidences that the different kind of different phenotypes with different metabolic rate have also advantages and disadvantages with increasing or decreasing resource availability. And climate change basically is going to be a decrease of resource availability because it's an increase of cost. So that is something on which we can try to work and to build a virtual research environment specifically for that. Thanks a lot. I think I almost took the time.
Thank you, Mr. Basset. There is time for a very short question. Anyone?
Just for curiosity, is there any plan to collaborate with other countries in all this? Because I think it's very almost Italian fate, right?
The money are Italian, but the idea of both project is to have the largest possible international involvement. And for the National Biodiversity Future Center, that's one of the spokes, that is spoke 8, that is related to outreach. that has a specific plan for reinforcing the international relationship. In all of this game are deeply involved with the research infrastructure, and then research infrastructure means that all the project and landmark will take advantage of the whole network of collaboration. So the only thing that is purely Italian at the moment is the budget. We hope that we will be able to use in a proper way and in an effective way, and the presentation is a sort of call for collaboration. That's for the question, because we need to have collaboration, and the other thing is that we are going to build this virtual research environment. At the moment, apart from the infrastructure, that is going to be the LifeWatch infrastructure, it's going to be Tesseract plus Navi ERIC, then all the other issues are open. So if you are interested in the topic and you have an idea, you would like to test the question, then you are really at the proper time to send us a message and say, hey guys, we would like to collaborate. I think that this question is interesting. We would like to have you helping us, and then we will be bring everything into the virtual research environment. So, fantastic question. Thank you so much.
Okay, thank you, Professor Basset. I'm going to welcome the next speaker, who is Santamaria from Doñana Biological Station, who is presenting a talk towards the adaptive co-management of Andalusian ecosystems, linking historical information with innovative science policy processes at the Doñana National Park.
Great, thank you. Thank you all for being here to lunch. I'll go quickly through what we're trying to do to link the research infrastructure to management strategies and interventions using an adaptive co-management framework. So briefly, I will go first to why we use this framework. And basically, the idea is that anthropogenic impact on natural world is happening and increasing at an accelerating rate. And this causes undesirable and often unpredictable responses. This was to illustrate the sequence we have had in the last decade of regional fires that were unprecedented in the decade, from those happening in Russia, those happening in Australia, those happening recently, for example, in Spain and France last year. And the thing is that to address this challenge, our past policy framework is ill-designed, because the classical framework is the slow build-up of evidence from research to policy that takes 1 to 2 decades to consolidate knowledge. And we have seen recently in the COVID pandemic that actually that can be sped up if necessary, using more flexible and approaches strongly linked to policy making, and that's exactly the kind of approach we need. And what was the reason for this? The main reason is 2 things. When you take decisions, especially in social and natural systems or in natural resources, you have complex systems which have very high levels of uncertainty, coming from all kinds of disturbances that you know will happen, but you don't know when and to which strength they will have. And normally there is a lack of single optimal solutions. Very often, a solution that is optimal for certain goals is suboptimal for other goals. Now that causes a problem in the traditional system of looking for a single solution, and is compounded by our own cognitive responses to these 2 factors. When we are taking decisions with high levels of complexity and uncertainty, very easily what we get is an increase in anxiety and defensive positions that make negotiation much more difficult. And brings me to the second aspect, which is the fact that the lack of direct stakeholder involvement in decision making not only results in a distrust and resentment of the stakeholders, and when we expect them to be collaborating, very often they are actually contesting the decisions we are making. So, what we are proposing, or what people doing collaborative adaptive management is proposing, is that managers have to realize that management interventions are actually experiments, and they are never certain of the results that we get. And once you accept this, your framework changes a lot, because you can design your policies to do three things. Avoid no-return responses, even if you think they would be the best. If you have a risk of a response cannot be corrected, you have to avoid it. Identify knowledge gaps and try to resolve it at the same time that you're applying your policies, and design your policies to adapt to the unexpected. And this is the three aims that adaptive co-management, as is being called mostly in the last, for example, cost of the Horizon program, formerly collaborative adaptive management and adaptive governance schools were fitting into this, was designed to do. And basically this combines collaborative adaptive management, the process of making decisions that are flexible and adaptable, with processes of participation and collaboration. So it has two elements. The first one is co-design and co-management, which requires a build-up from the identification of stakeholders, institutional analysis, then collaborative modeling techniques, or techniques of doing participatory knowledge sharing, and finally structured decision making. So a whole battery of techniques taken mostly from social sciences to ensure that everybody participates at equal level in the decisions. And the second aspect is learning by doing, which is a cycle of decisions in which you set very carefully objectives that are key for the whole process. You will see in the later steps. You plan your interventions as experiments, so you take into account your uncertainties and your knowledge gaps. Then you implement the interventions, you develop monitoring programs that are tailored to the questions you have, and you plan from the beginning a cycle in which you will review your assumptions and refine your interventions. Now, we have been using this framework since about 2000, 2005. We started to work in the Doñana area during the Doñana 2005 programs, doing institutional analysis and a number of things. We published a number of analyses showing that the management system there is a rigid institutional system in which innovation is very hard to be introduced. And lately we are trying to use different small-scale initiatives to introduce flexibility and so successful examples of how adaptive management will be done. So within the LifeWatch program, what we are doing is using the adaptive co-management framework to make an inventory and a benchmarking of all historical management interventions that were done in Doñana National Park. Because we realize there is hundreds of interventions that have been done in the last decades. And even people doing research and management there, they are sometimes at the spots where a number of things have happened that have never been recorded, and what they think is natural vegetation, for example, has been managed for 2 or 3 different objectives. And the result is a geodatabase of management interventions and associated biodiversity data, and more importantly, is a process in which we try to create the conditions for managers to have to do all the steps that adaptive co-management requires. I will show you 2 very small examples. So we are now busy reviewing all interventions since 1998 for the time being to 2020. We have reviewed today about 570 interventions belonging to almost 300 projects. This is the timeline, just three illustrative elements from this. First, you can see the funding cycle. You know, this is the financial crisis. So you can see that in all aspects of science and management, many things are determined by the money available, but more important is there is a 10-year cycle of high intensity of management interventions. And what is quite interesting is that a number of these management interventions in these peaks are setting up the policies for the next 10 years. Many of these projects were evaluations of things and development of strategies for the next 10 years. So inherently, managers are using a cycle that is very amenable to an adaptive management cycle. And if you simply are more rigorous in putting the objectives and planning the management cycle, then things will work nicely with the timing they have. Now, most intervention of these 570 lacked most key elements to adaptive co-management. Most of them lack stakeholder participation. Most of them lack clear overarching objectives. Virtually all of them lack specific objectives that were given an effect size on a given time. They didn't have a long-term monitoring, and they never planned for learning amplified. There have been things that have been repeated for the last 20 years without really looking into whether they work or not. So very often they do some monitoring in the first 3-4 years, they decide it works, and then you have 20-25 years of management actions, assuming that things are the same that they were in 2000. And imagine all the things have changed in the last 20 years only on the climate side. So we selected a couple of interventions that we know better, and we tried to fill the gaps to show how it could work. So we took interventions related to vegetation management for overgrazing. The park has a major problem with overgrazing from white ungulates combined with livestock. Actually, most of the problem comes from an increase in livestock pressure. That, when it's combined with the decrease in rainfall, especially in the spring, is causing huge overgrazing problems in some parts of the park. So we took 2 interventions. One were 23 small exclosures created for research and vegetation management 25 years ago. So this is very interesting because it's 25 years of accumulated exclosure from herbivores in the marshland. And these exclosures are quite famous because if you go there, you will see vegetation is, in the first 2, 3, 4 years, it became 1 meter tall, outside is highly raised. But the interesting thing is, after that, little change, but most of the things that are happening in the soil. Plant biomass is almost an order of magnitude higher inside the exclosures. What is happening outside is that there is very strong compaction, and carbon and accumulation is taking place only inside the exclosure. So basically, overgrazing is causing a major carbon release or a lack of a carbon sink throughout the Mars. There were another 86 exclosures created in the limit between the marshland and the sandy area to protect recruitment of the tree vegetation, which is a major conservation issue because it's not recruiting. So what we did, these were created 20 years ago. Some of them have been broken now and then. So what we did is we used the whole series of orthophotos to look when they were open, and we monitor recruitment in these places. Okay, this is slides you cannot see. So basically what we did is we went inside and monitored all the recruitment and compared recruitment in exclosures and control areas, and single result is control areas have basically no recruitment. Exclosures are working, but some are working very well, some are working very bad. And this is related to the place where they are, to the moment when managers decided that they could be open because existing juveniles had escaped grazing, and to the kind of animals that were coming in. So we are now looking at those details to try to provide guidelines on how to manage them. So this was a snapshot of what we are trying to do. Basically use online tools for information management to support decision making and dynamize the science policy interface. And our objective is that defining required observation input for this database will kind of force managers to identify action and monitoring objectives, and that will foster future evaluation and learning cycles. So try to make explicit link between online tools and management. Thank you for your attention.
There is time for questions. No questions? Okay. So we'll go to the next speakers. So I'm gonna welcome on stage Sonia Sanchez-Navarro from Doñana Biological Station, who is presenting a talk on wind energy and bats, a match made in hell.
Hi, everyone. My name is Sonia. I work in the bat group in the Doñana Biological Station. I'm going to talk about a little bit of wind energy and the impact in bats. This is the right. Okay, so we know we are in a limited planet, and indeed we don't care because we are overpopulating the world, we are polluting the world, we are filling the world with plastic, and we are depleting all the resources, and we are having taking too much from them, that we are using like 1.5 planets. Okay, today, okay. We are using more than 1 planet, almost 2 planets. 2 planets is the overall in the world, but for example, the States are using around 5 planets. For example, in Switzerland, they reach the Earth overshoot day like 10 days ago or something like that. So they have used the planet in the whole just in May. But there are some like happy currents today, and there are people talking about sustainability and green energy, some Maricondo and reusing and minimalizing and reusing things second-hand, a lot of different things like labels of zero emissions or carbon neutral or that kind of things. But we are in a very difficult position nowadays. So wind farms are necessary. They are renewable. They are clean, and they are very, very green. But I'm not sure if we can coexist. That the biodiversity can coexist with the wind farms, because nowadays it's a really huge problem for bats. They kill a lot of bats every day, everywhere in the planet. And for example, our study area was Cádiz. Cádiz has a very special situation. It's in the south of Europe, so a lot of migration of birds happen in that place. Besides, it has a strong wind from the east and from the west. As a result of that, there are a lot of wind farms and a lot of new proposals, so that's a little bit scary. The first wind farm was settled down in 1992, and it wasn't until 2005 when the first bat fatality was found, and also the first fatality was found, because the surveillance problem, even when they look for carcasses every day, because they have a really strict surveillance program, they look for soaring birds and raptors and really huge birds. they also stop the turbine when a flock of birds are coming really close to the wind farms. So the first, oh no, okay. So far we have like 3,800 of bat fatalities just in Cádiz. That is really sad, at least for me. We can find bat fatalities all the year, even when in winter there are less activity and they're supposed to be hibernating, but it doesn't like that in Cádiz because we have a really mild weather, the temperatures are not really low, and the rain is not happening a lot, and they have food, they have insects all the year now. But the 90% of the fatalities are in the summer and in the early autumn. Another data we have is that we know for sure that bats can fly with high wind speeds, but not too much. 88% of the fatalities were found at wind speed below 6 meters per second. And another data we have is that most of the fatalities were found at around 16 meters from the base of the turbine. And with all of this, we have a problem and we have a solution because there are a lot of tools nowadays, a lot of algorithms that you can set all the parameters of the variables, and you can try to look for the best time to stop the turbines, for example, or to high a little bit the current speed of the turbines because they don't have to start working at 2 meters per second, for example, because they are moving and they are killing bats, but they are not producing too much energy. It's something that the company can try to pay for. There are a lot of strategies of this around the world. We have a lot of them in North America. They have money, and also they have the compromise of the wind companies. But in Europe, we are doing a lot of work recently, and in Croatia and Romania, they have experimented that type of measures, and they have stopped the turbines during the nights in summer with low wind speed and everything, and they have reduced the mortality from 60-something to almost 80%, which is a lot, taking into account how many bats we found there. So everything is wonderful because we have a problem, but we have a lot of the patterns, so we know more or less when everything happens. So we have tools. We have a lot of studies of reference, and we have a really good study area, which is Cádiz, and we have the data of the mortalities. But it's not like that because the observed fatalities that we found in the countryside are not the same with the real fatalities, and I'm going to tell you about why. Usually we correct for 3 variables. One is the search efficiency, the other one is the search surface, and the other one is the carcass persistence in the field. So that is, in other words, how to say how well they look for and how much they look for and how often they look for. So as I told you before, in Cádiz you search every day because of the migration, the raptors and everything, but that is not like that in the whole world. I mean, in some places they look for once a week or once a month or one every 15 days. And with the search efficiency, for example, we have different kind of wind farms. We have wind farms with a lot of platform and roads, and wind farms without any platform, and we have crops, really tall crops sometimes, and it's not the same to look for in a place with high visibility, with a low visibility. In Cádiz, for example, we have hunting grounds or livestock, places with livestock, most of the time wild cattle, so it's not really safe to look for carcasses. And then we have the eastern winds and the western wind. We are that they are really hard, or even the sunny days in summer or the rainy days in winter. And then we have the person who is looking for. Not everyone is the same, not everyone likes the field, and not everyone likes to work, to be honest. And then that is an example of the platform and growth of real wind farm in Cadiz, and those are the real fatalities in that wind farm. So if you can see that all the fatalities have been found in the platform, all of them. There is no one outside these places, and if you can find one in that place, they are the same probability to find the same one in that place, and the same one in that place, and the same one in that place. So maybe we have 4 times more fatalities than we think we have. And the other thing is the persistence of the carcasses in the field. In Cadiz, we have found sometimes that in 3 or 4 hours, all the ants and the wasps, and that they are here, they can leave the whole bat. I mean, a bat could be from 4 grams to 40 something grams. It's not too much work to do, but it's something. So we ran a lot of tests in Cadiz, and we found really sad numbers because the efficiency was around 70%, which is nothing, and they know that we were testing them. So I mean, it's like, come on, try a little bit better. They were looking for in around 15% of the surface, and the carcass persistency was around 2.5 days, which is more than enough in Cadiz because you look for every day. Doesn't matter. With everything, we have data from the first paper, the first study, which the numbers were around 0.64 baht per turbine in the area. But after the formula, the algorithm, and everything, we calculate the estimator to see how many real estimated bats could be dying in Cadiz, and the number was 60 times bigger, 66 times bigger. It was around 41.1 bats per turbine. If we extrapolate that to the 970 turbines that we have in Cadiz, we can have around 37,000 bats dying every year in Cadiz. If we extrapolate to Spain, for example, with more than 21,000 turbines, that could be numbers like this, which is really scary. So I have nothing against the green energy. I think that renewable energy is good, but we have to try to coexist with biodiversity. They have a lot of money, and they can lose a little bit of this money because they don't start the moving of the blades a low wind speed, or they can stop the turbines during a time. So e-science is wonderful because it gives a lot of tools and solutions, but when you ask for the data, for example, to the administrations, they don't have the data. I mean, I have asked all the provinces in Spain for the mortality data of bats, but they don't have it. I mean, they have a lot of PDF or even paper work in a basement, and if you want to, if you worry, you can go and search and look for the mortality and every report and try to take and gather the data for yourself, which is nice. So thank you for listening. I hope you are as worthy as me right now, and that is the thing.
Thank you, Dr. Are there any questions from the audience? Okay, questions? anyone?
I have a question about the extrapolation, because this morning we heard that there was a specific route of the bats to one of the wind parks. So is it valid to just calculate the basis and then extrapolate to all the wind turbines in Spain?
I mean, in Cádiz they did well. Is the best example that we have. I mean, they look for every day, and you have people every day in the field since sunrise until sunset because of the birds. I mean, they supposed to do it. Great.
Yeah, I understand that the data are good, but is it the typical situation for all turbines in Spain?
Yes and no, because we have no idea, because we don't have the data, and when we ask for the data, sometimes they say, no, we don't have anything. But in Cádiz is the worst province in Spain, but we have a lot of them more. Like in Soria, you can find a lot of fatalities also, in Catalonia also. We have fatalities almost in every province. So we think that maybe it's not the same, but we have 900 turbines. I think in Castilla y León there are many more. So that's
Ben Cristina at the University of Amsterdam. So recently we've had, I think, the first successful trial in the Netherlands for wind turbine curtailment during deep migration of passerines. And one of the issues that the team needs to work with is the information on delivery of the turbine operators. Now, from what I understand here, this is a problem with the bats, that it's year-round, that they are being hit by the blades or barotrauma by the blades. So what is the strategy here to inform a turbine operator? For us, for example, we need to inform them, I believe, well in 72 hours in advance, which has a lot of implications in how we deliver the information in terms of forecasts. Is this a continuous effort for the turbine operators from your side? So is there a way that you alarm the turbine operators to slow down the turbines or to stop them completely, or do you have another methodology for this?
They spend 10 seconds in stopping the turbine. You are in the I mean, I don't know if I understand the question right, but when you are in the field working with raptors, for example, you are watching the raptors coming to you, and you call the operator, and they stop the turbine in 10 seconds.
Okay, this exactly answers my question, thank you.
But not during the night, because there is no
Yeah,
one
because you can't see
for
no.
doing
So
it.
in the case for the passerines, at least what our group did was to make a predictive model which, based on forecasts, would estimate what the optimal time of migration would be. And then a few of these moments are being picked in a year because it's a cost balance that the turbine operator has to do, and they selectively shut down turbines to mitigate at least some conflict. But those are very few moments, and that has to be done at least 72 hours in advance as per agreement with the turbine operators. But we do not have people on the ground to call and ask for a turbine shutdown. But, okay, it's very interesting. Thank you.
One last question.
Yeah. If I understood well, you mentioned that below a certain threshold of wind, and probably during the night, it would be the best, to stop. Could it be useful to calculate for the operators which is the reduced power, or at the end, which is the cost for them, and just, to balance, and why not even, for example, ask for the government if they can pay, some money in return. Because I don't think there will be a lot of money, given that it's during the night, there is less, demand, and also with low wind speed.
I mean, I think it's like they are afraid that you can ask for this legally, so they don't want to do it at the first time, because there are some calculations, and it's like less than 1% of the profit or something like that, and I mean that's nothing. They are working with millions and millions and millions and millions, and is nothing. It's even, I mean, in the law, when you kill a threatened species, that they are doing that every day, you have to stop the turbines for a while until the situations are solved and everything. So this much worse to stop the turbine for 3 months until the situation solves than to stop during the night, during the summer with a temperature and wind speed. And during the night there is less demand, for example, and you don't have to save the energy. I mean, it's easy to do it, but they don't
And
want
also
to.
it could be, as a kind of mark of bat friendly or something like that, that even it's maybe a greenwashing, but for them it could be, a return saying, in our company we are considering that problem, and if it's really 1%, it's the one that they can, allocate it later on for these, I would say, campaigns of bat-friendly company or something like that.
But we are trying that. Now the administration is working with us, so I hope we can do that in a way.
Yeah, final question.
Okay, really fast. I'm curious because bats are attracted to sound, right? So is there any study about if they are attracted by the sound made by the turbine or something?
That was one hypothesis at the beginning because they make ultrasound when they move and everything, but I think that we have not really clear what happened and why they go there, because sometimes you make a pre-study and there is nothing there, and when you set the turbine there are a lot of bats there, so they are attracted by the turbine somehow. Most of the thinking are going to that insects like the hill topping that they call it, what is looking for a tall structure in the middle of the space. Bats are going up after the insects, so that maybe we don't know. I mean, we don't know what happened and why they are there.
Thank you, Dr. Sanchez. Moving forward, we are going to have the next talk, and I'm going to welcome Dr. Ricardo Diaz Delgado, who is giving a talk on upscaling phrenology, water and CO2 fluxes with remote sensing for the validation of Earth observation products.
Thank you. Yes, good afternoon, and thanks for being here. Yeah, we changed the topic. We moved to the use of remote sensing to track the ecosystem response to climate change, and also the accuracy that the Earth observation products have in the use of these monitoring purposes. So the idea is that we have this project somehow, and we are leading this work package, which is dealing with developing some protocols and indicators to monitor and assess what we call land condition at different scales. It is mainly a pilot study looking for co-location of two research infrastructures, LifeWatch ERIC from one side and the other side, ELTER. So the idea is to use the monitoring program of the Doñana Natural Space, which is also a site in the ELTER network, and to integrate the results into the visual research environments. So as you can see there, you have, this is the research infrastructure landscape in environment and in the health. So we have a memorandum of cooperation, and we aim to produce and reduce the funding, and at the same time produce the good results for the two infrastructures. So as many you may know, many of you, ELTER is a research infrastructure that is nowadays under the preparation project phase, and then we consider several sites in Europe, but it's also part of ITINERIS network, which is a global network with the main aim of the long-term ecological research. And in Spain, we have 13 sites for this ELTER Spain network, from which you will find Doñana, which is one of these sites. Actually, under this infrastructure, we have selected and identified several what we call standard observation variables that will be measured for every site in the ELTER network. And then we are producing for Doñana an example to a pilot study, as I said, to address some of these specific standard observation variables, because this area, as many of you know, it's not only protected for biodiversity and ecosystems, but also for the equipment that we set up in the field. We have these research facilities, and it's very, very helpful for remote sensing, because we have flat topography, low cloud cover, and what we call contrasting radiometric signatures, and different ecosystems. And on the base of that, of everything, we have this long-term monitoring program. And in addition to this, we have these proximal sensors in the field that allow us to do this upscaling. We are looking for providing data for calibration and validation networks for Earth observation products such as Copernicus and GEO. So we know that we have many, many advantages of using remote sensing in tracking ecosystem response to climate change, from the global vision to the consistent time series of images, having a large sample size, which is also very useful, and retrieving biophysical parameters that are very interesting for us, like gross primary productivity. But we still have some cons, which it may turn out to be requirements, which are, by the way, sensor calibration, requested to have a certain accuracy for the products that we use, and the same for validation through upscaling. Upscaling meaning using the in-situ data to validate the data that is produced by these Earth observation products. So we have finally to integrate these different data sources that we may have for a specific site in order to track these ecosystem changes. So we do have a long-term monitoring program in Doñana since the beginning of this century, and especially one program which is made at landscape scale, dealing with habitats, ecosystem functioning, and services, as well as land use and land cover. We use remote sensing, including these proximal sensing, sensors in the field, or UAVs, and landscape ecology, and finally we produce reports, maps, and trends and anomalies that we will see today. So the main features can be biophysical monitoring, but it's also in relation to the structure and function of these ecosystems. So from all the most than 120, as far as I remember, standard observation variables from ELTER, we have selected some of them for this pilot study, which we consider to be indicators and ecosystem services such as land cover phenology, not only for plants, but also for wetlands and other different land covers. Land surface temperature, which is very essential variable for the energy balance. Surface water, which might be summarized for temporary waters as hydrogear. And we are also interested in soil moisture as a driver of the plant stress. And finally, we also try to upscale the information collected at in-situ level with the ecovariance towers on the water and CO2 fluxes in order to understand the productivity and the evapotranspiration patterns. As for phenology, we have developed an application by which we are able to retrieve what we call the phenology variables, such as the start of season, the end of season, the length of the season, which might be revealing the effect of climate change on the different land covers that we track. So we track this at the satellite level by using the time series of images, for instance, for what we call vegetation indices, and also at the site level using what we call phenocams, which are deployed in towers continuously observing the same land cover and tracking as well the phenology processes in the land cover that is observed. So we can compare both and see whether these products are accurate enough to provide this indication. So what we saw so far is by validation, we are really evidencing what are the main impacts on due to this stream drought period that we are undergoing in Doñana in the last 4 years, in which you can see, for instance, the dramatic reduction in February last year of different land covers, for instance, heathland, junipers and woodlands, pine woodlands at the satellite level, very coincident to the ones observed by the phenocamps in situ level. And in addition to this, we are obviously tracking a decrease on the length of the season in relation to phenology metrics. When we deal with the delineation of water bodies, for instance, Doñana marshes, which are temporary marshes that become flooded every year and dry out every year, what we see, we can see a little bit the trend for the last 50 years, almost 50 years, in which maybe you don't see the colors, but in which you can see the main negative trend for the whole market inside the national park, and outside the national park you can really reveal the increase in hydro period in the time that the water remains in a specific point in the area. Same for water level, so for the shorter period, but the water level has been increased a little bit in the north, but still decreasing in the south of most of the marshes, mainly in the south. So revealing the effect of the reduction of the flooding inside the Doñana temporary marshes. As for water and CO2 fluxes, same for Doñana marshes, we use the Decadal towers that we have set up in the last 6 years in the Doñana Biological Reserve. By using just one in the marshes, we have adjusted a two sources energy-based method to understand what is to estimate the gross primary productivity that you can see here for 2 years, the 2011 and the 2012, being the 2012 drier than the 21. So the gross primary production, as you can see, total gross primary production was much lower in this year, as you can also see in a spatially explicit way for the dry year. So the method is working fine with a very good root mean square error. And finally, we are also using airborne hyperspectral sensors to upscale at an intermediate scale between the sensors in the field and the remote the Earth observation images that we have available, for instance from Sentinel-3, by which we retrieve this land surface temperature together with the emissivity that is helpful in providing the input for the balance, the energy balance, and then retrieve the evapotranspiration. And on the other hand, we are also focusing on soil moisture, by which we are using non-invasive sensors that are very, very helpful at this for upscaling, because they can retrieve the information from soil moisture, not at very such as the typical sensors and probes at puntual scale, but also as considering effects or in an area surrounding the place where we set up these sensors. These are the neutron cosmic ray sensors that can provide the very frequent information on soil moisture for the 300 meters radius around the place where we have this sensor. So in here you can see this chart, for instance, the relationship between the rainfall and then the increase of the soil moisture day by day, measured at the minutal scale. So finally, all the products will be made available through this virtual research environment, especially for the Elter network using data labs, which is one of the interoperable options to provide this data using the what we call the Pheno app, which is already implemented and available, where you can retrieve so far the phenology. Maybe by the end of this year, we will be able to provide for any site in the network the land surface temperature and the water bodies delineation by selecting the different, for instance, for the phenology, the different metrics, and by which we are using Google Earth Engine to design this model, and then also the specific libraries that allow us also to download the data provided by Copernicus high-resolution vegetation and phenology products, such as the ones you can see here, for instance. This would be the start of the season for the specific year in the Doñana site. So most of the products are already being published through BEeS tools, through the IPT, and also through Zenodo. So with this, I think my presentation is done. I welcome you.
We have time for a very short question. I have a question actually. I was wondering which data are going to GBIF and which data are going to Zenodo, how you're going to treat the different data you are collecting.
Thanks, Cristina. This is a good question because, as you may guess, the information on the data coming from remote sensing images, it cannot be really structured and made accessible in the same way as you have other kind of data. So finally, what we do through the BEeS is to provide only metadata, and then use other repositories to provide the data itself.
Okay, thank you, Dr. Diaz Delgado. I'm gonna welcome the next speaker of this session, Ana del Anguila, sorry for my misspelling, from LifeWatch ERIC and the Andalusian Institute for Earth System Research. She's going to present evaluation of aerosol over Sierra Nevada and mountain protected area using ground-based and satellite measurements. The floor is yours.
So, good afternoon, everybody. Yeah. So, I'm Ana del Aguila, and I will talk about the evaluation of aerosol over Sierra Nevada, a mountain protected area, using ground-based and satellite measurements. I'm working in LifeWatch and collaborating with researchers at the University of Granada from different departments. So I will give a brief introduction about what are aerosols, and they are defined as the suspension of solid or liquid particles in the atmospheric air. And as we can observe on the left side, there are different origins of aerosols. The natural origin, like those of volcanic eruptions, wildfires, pollen is also an aerosol, and very important that I will focus later is mineral dust. On the other hand, there are also anthropogenic aerosols, like those emitted by cars or industry, etc. And they can be visible, like in this image on the bottom. This is the city of Granada, where there is an aerosol layer. So we can observe even the pollution sometimes. So the aerosols, they don't have only different origins, but they also have different sizes and shapes. And if they are very fine or small, they can penetrate lungs and they can lead to respiratory diseases. And last but not least, they also, of course, affect climate change. And the last IPCC assessment report, they highlighted the negative relative forcing effect that they have. And they are widely studied, so we wanted also to study them in our ecosystem of Sierra Nevada. And our main goal was to answer the question how atmospheric aerosols are affecting Sierra Nevada high mountain protected area. So for that, we are monitoring aerosols using remote sensing at surface level and satellite measurements. First, we have calibrated and validated the aerosol estimation from the satellites with in situ instrumentation. And the ultimate goal is to create a tool for aerosol monitoring in Granada and Sierra Nevada. And all of this work is developed in the context of the Smart Mountain project, as I said. So the study area, for those who you might not know, it's Sierra Nevada National Park, which has looks like this in winter when it's snow, and it's located at southeastern Spain. The orography is quite complex. It has altitudes up to 3,300 meters, and we will talk about three measurement stations of aerosol properties. One located at Granada in the valley. The other one is located at mid-altitude at 1,800 meters, and the highest one is located at 2,500 meters. So in this study, we have compared different data sets, and the variable that we are comparing or investigating is the aerosol optical depth, AOD, at 550 nanometers. And this variable gives information of the aerosol loading in the vertical column. So the higher the AOD is, the more amount of aerosols there are in the column. And we have validated MODIS satellite data of AOD against AeroNet. These are as a network of photometers, and MERA-2 analysis. So they have different time coverage. This goes from 2000 until present, and the reanalysis data has more than 40 years of coverage, and they have also different pixel resolutions. MODIS has 1x1 kilometer, and MERA is wider. And they have compared with these three measurement stations, as I said, at different altitudes. They have different time spans. And also, I would like to point out that the measurement stations in the high mountains has a smaller time span, and because of the difficult access to these remote stations and difficult human access to them. So the results of the validation are successful. These are for the three stations, and on the top panel for MODIS and on the bottom panel for the reanalysis data. So the correlations are high and in agreement with the literature, and the AOD values are as expected, with decreasing AOD values with altitude. So this is the highest station, and you can observe that the AOD as expected is smaller. So we have also, due to the previous results, we can perform temporal series analysis, and now we are able to characterize the AOD with different data sets at different altitudes. And also in this figure, this is MODIS data of AOD, and we can provide and characterize the AOD long term at different altitudes and in this complex orography of the high mountain range. We have also analyzed the interannual variability of AOD. This is a map of the last 20 years. And as I said, we are the measurement station, the AeroNet stations are were in agreement. We have validated that, but we observed these high AOD values that we were not expecting. So they occur at altitudes above 2,600 meters above sea level. One hypothesis, well, we believe that the models provide persistent high AODs with high albedos. And we have also compared with the ecosystem types with this map. So we can observe that these high AOD values correspond with the red part of this ecosystem map, which is the high mountain grassland and tangents and rocks, which have high albedos. So this probably is causing these high outliers. Finally, we have also analyzed the long-term, the different type of aerosols with the reanalysis data. So the pixel size is higher, but it contains part of Sierra Nevada and part of Granada. And with this, we can characterize the different type of aerosol like black carbon dust, organic aerosols, sea salt, and sulfates for the last 40 years. And we will focus on the dust because we have had several dust complaints during the last few years. And I've computed the annual means for the last 40 years, and we can observe that there is a positive trend in the dust surface mass concentration in Sierra Nevada and the whole area of the pixel. And I would like to make a comment about the World Health Organization that they fix the threshold of 50 micrograms per cubic meter of surface mass concentration as risky for the human health. So we wanted to quantify how many days per year we have exceeded that threshold, and these are the results. So on the top, it's how many days per year for the last 40 years that we have exceeded the threshold of 50 micrograms per cubic meter, and on the bottom panel, how many days per year that it's been exceeded 100 micrograms per cubic meter. So this would be extreme dust events or extremely dusty days. So we observed that in 2022, these values are the maximums. So we can affirm that in this year, the number of days are the highest dust concentration observed in the historical series of this reanalysis data. And these can give images like this of Sierra Nevada lakes that they color the snow in brown because of the extreme dust events that they have been. And we can observe that they also can affect the snow coverage, as in this image. And if you want to know more, these are some publication that we did in the web. It's in Spanish, so yeah. So the conclusions are that we have successfully validated the AOD at 550 nanometers for Arnett with MODIS and MERVA2 in the Sierra Nevada National Park. Second, that we have assessed the long-term analysis of AOD in Sierra Nevada. We have also found that in 2022, it has been the year with the highest Saharan dust concentration, with more dust events in Granada and Sierra Nevada over the last decades. And as an outlook that we are planning to perform further studies to quantify the effect of dust in climate and the high mountain protected environment of Sierra Nevada. So thank you very much for your attention.
There is time for questions from the audience. I have a question. I was wondering, if there is a plan to inform managers about these results, because some of them are critical, I think, so they're very relevant.
Yes, actually, the goal is to make a tool available for the society, so they can have this information, this data, not only about aerosols but other parameters. We are in collaboration with several departments in Granada, and this tool will be available so policymakers or society researchers can have this information available and they can take measures.
Thanks very much. Is there any chance of relating your data on aerosol content in the air with the number of respiratory problems treated in Granada and local cities? Make a direct relation?
It has not been done. I mean, it would be very interesting, but I don't have this data about diseases, respiratory diseases, but that would be a very interesting study.
Other question?
Yeah, just for curiosity, I was wondering if you are aware that, for example, in the Netherlands, they have developed a device, it's a gadget that you can connect to the smartphone, and they can estimate the optical depth. And they have correlated quite well with most of this data. I was wondering, for example, if there are some hikers in the top area that can use that, and maybe they can tell you if there is this, because you mentioned a potential bias because of the albedo. I was wondering, well, you know, it's quite cheap. I will give you details on that, but they have tested in the Netherlands mainly, and it seems that it's a good option, you know, and also to involve hikers and citizens to collect this kind of data.
I think that would be really interesting. Yes, it's a very good idea, because we were thinking about how to bring instrumentation to the top mountain, but it's not that easy. But if this device is providing good correlations, that would be worth trying. Yeah.
Okay, thank you, Dr. de la Muela. We'll pass to the next speaker now, with Maria Luisa Antequera Gomez from the University of Malaga. She's presenting Environmental and Biodiversity Climate Change Lab.
Hello everyone. I would like to begin by introducing myself. I am Maria Luisa Antequera from the Department of Language and Computer Science at Malaga University, and I am going to present the project that the title is Environmental and Biodiversity Climate Change Lab. And yes. So, what is this project is also known as the acronym NVICTULAB. So, for now on, I'm going to refer this project like this acronym. So, what is NVICTULAB? NVICTULAB is a record research environment, or BRE, that covers collaborative tools that let the data storage from different sources, and also the integration of different services like data management, communication, or so on. So, in this project are involved several partners, all of them from the University of Malaga. First of all, the Big Data Group, which are the group that I am part of, is involved in big data analysis and also data management, data storage, and all these tools. The second one is ETC-UMA, which is involved in map creation and remote sensing, and then there is a cluster of groups which cover soil, water, fauna, flora, and air aspects of different ecosystems. And then this is ERIC research, which cover solutions regarding to Internet of Things. For example, the creation of specific sensors to measure specific variables of water. And finally, there is a group that is involved in supercomputing that is mainly implicated in metabarcoding and metagenomic analysis. The pilot area that we select for this project is these 3 regions, all of them located in the south of Spain, concretely in Andalusia, which are Los Alcornocales Natural Park, Sierra de las Nieves National Park, and Cabo de Gata Níjar Natural Park. All of them have different climate patterns and also different biodiversity and geography and hydrogeographic condition. So this election of these sites is a good opportunity to explore how climate change could affect these ecosystems. First of all, regarding data storage, in the Pictura portal, we create several forms to data collection and data management from the different partners of the group. In addition, we create a similar option of form, but in form of an application where the researchers can go to the field, for example, and collect in situ the data without using notebooks or whatever, and also with or without internet access. Regarding service integration, in collaboration with the FONA group, we developed several applications like the first picture is regarding the labeling of different vulture species, completely the Rumpels and European vulture. And then we will process these images using artificial intelligence techniques. And in addition, they put sensor in different vultures, and we can then, using the series analysis, manage their location and probably make future analysis. Regarding remote sensing, we create a new land cover map that improved the previous created one, this small one, from Copernicus project, because the classification of the different lands is better. There is an example here in Jaén. I don't know if any of you know it. The first classification is like a forest and a group of olives. And in this new classification, we don't classify like a problem. So we think that this new classification improves the better classification one. And also we are working on a forest cover classification regarding specific species in each forest. The primary tool that we have developed in this project, that we use in this project, is the management of scientific workflows. So, first of all, I would like to describe the goal. Here you can check the QR if you want to see the paper regarding this publication. The goal is an ontology, is the baseline of this, and is a conceptual framework to connect and define different concepts in order to can create next workflows. Okay, and to create these workflows, our group have created Titan software platform to integrate and create the workflow using the different components. So, at the moment, this project have more than 142 components related to data collection, data processing, data analysis, data flow, and data sync. And in this picture in the left is an example, a visual example of the representation of workflow in Titan. Here is all the components, and you can see the number and the type of inputs and outputs. Then we deploy these created workflows in the platform César Vilas, and now we have already created several workflows from air, fauna, flora, soil and water groups as partner of the projects. And now we are working on creating more generic workflows related to life science. For example, generic machine learning workflows, with the idea that a scientific that doesn't know these tools or programming can use these workflows in an easy way. Now, the collaborative tools I'm going to talk about on this workflow that is already deployed in César. Regarding iGroup, we have created 2 different workflows. First of all is using a library from R that measure different pollen trends. So this is really useful, as I told you, because only using this workflow, the researcher doesn't know how to use R language, for example. And then we create a pollen forecasting workflow using deep learning techniques in order to predict the pollen season. Regarding fauna groups, here on the right there is a workflow that we create to automatic labeling of different pictures of animals using from camera traps experiment. I don't know if you know, this camera trap experiment usually have a vast volume of data, and it's really useful for the researchers to have an automatic labeling of all the pictures. And here in the left there is an example. For example, the first one is a unique animal. This one is 2 individuals, like these 2 mongoose in the picture. And the picture below are at night. For example, this is a small mouse, hard to find in this picture. And here is a pair of animal, like this rocks. Related to flora, we create, using the form that I told in the beginning of the presentation, a phytological inventories in different databases that they can then use for make statistical and data distribution analysis. So there is an example of output that the workflow obtained. For example, you can see the distribution of the different taxa in the 3 different locations that I told at the beginning. Regarding soil, they also use the forms to store the data in the database, and they use all these samples to make PCA analysis in order to classify or see if the classification of the variables or which variables are important to classify in each natural ecosystem. And finally, regarding water, we perform 3 different workflows. First of all, a statistical analysis from precipitation and temperature. This is an example, a table of means and median of this precipitation during, for example, a year. And the potential evapotranspiration and effective rainfall, and a 3D interpolation using digital elevation models. And finally, I would like to share to you our social networks, and below this is the website of the project, that here is all the events that we are working on now and in the future. And this is the website of the project, and also from our group. And mainly I focus in this squad because it's the YouTube channel. It's a list of YouTube that is talking about specifically all the things that I was talking about now in this presentation, and it's continuously updated. So thank you very much for your attention.
Thank you, Dr. Antigera. Congratulations for keeping the time. And any questions from the audience? I was wondering if maybe I missed part of the presentation, I don't know, but are these tools available to be used, these virtual research environments?
yes, there is.
Or is it work in progress?
It's still available, but it's true that we are working on because we are working in the interface.
Yeah.
So we try to order the workflows between different partners. So, but it is true that now you access to the website, you can see the structure, you can check it. So now it's available.
Okay, yeah, it's a complex task and something about it. And how actually, well, it's a logistic question, like how difficult, well, complex was to coordinate all the activities among so many different partners working on different topics.
Oh, it's difficult because you know there is a lot of partners with different topics and they have different domains. But it is true that we try to make demos usually, and also we try to email them when we have a problem or an issue or a solution. I don't know. So it's difficult, yes, because there are several partners, but it works.
Great. A question from the audience? Over there?
It's about, thank you for this very impressive overview. But I have a critical question according to the vegetation and the flora. So you said that, well, phytophysiological data are recorded. So the phytophysiological units were defined in the middle of the last century. And as long as you have certain diagnostic species, you will still have the same community, even if it changed substantially. So if the canopy has changed, if there's change in dominance patterns, so it's not reflected. We will still see the same unit. So it's very difficult, if not impossible, to link phytophysiological mapping with remote sensing, to my understanding. How do you solve this problem?
Yes, in this case, the remote sensing and floras go separately. In case of the floras group is made in 3 different databases. One related to physiological inventories, which include the communities of plants, species, index of abundance of these plants, and then apart, when they go to collect into the field, they also make inventories that regarding the flora. I mean, take the plant and make and collect in the inventories of the university. So, but in case of remote sensing, it's different because we are working on create a forest map, and flora is a different way because in case of remote sensing, we are going to cover all the Mediterranean basin, and flora is exclusively of this region of Sierra de las Nieves, Alcorocales, and Cabo de Gata. So it's different focus. But yes, so the idea is different because each group is focused on the specific domain to obtain information, and then we can combine and see if this information is important or not.
Thank you, Dr. Tequera. We can move to the next speaker of the session, Maria del Carmen Montero Caranzas, Andalusian Institute of Agriculture and Fisheries Research and Training, who is presenting functional and biotechnological potential of the Tabernas Desert soil microbiome.
Hello everybody. Yeah. I'm Maria del Carmen Montero Caranzas. I work in the Andalusian Institute of Agriculture Research. And today I'm going to talk about something completely different that you have here until now, because we are microbiologists and we preserve bioresources, microbial bioresources. In this talk I will try to convince you that it's also really important to preserve those resources, not only because we don't know what's going to happen in the future in this changing context. The microbial communities that we have now, possibly in the future, will be different, and that means that we are going to lose a biotechnological potential really important. And then this is really it's crucial to start to preserve those communities right now and as soon as possible. Today I'm going to talk about functional and biotechnological potential of the Tabernas desert soil. This was a joint research between IFAPA and the University of Almeria. Drylands take out almost 41% of the terrestrial surface. In those drylands, we can see that almost 70% of them are covered by biocrust. But as you can see in the map, not many studies are made until now about those biocrusts or those microbial communities. The biocrusts are associations between soil particles, bacteria, microalgae, macrofungi, lichens, and biophytes that colonize the first millimeter of soil. In those niche, we can see a high primary productivity in the way that organic matter is used by the microbial communities in those arid soils to grow. In the way that in the lower layers behind that biocrust, we can see a very active and diverse microbial communities. As I mentioned, in spite of that global significance that the drylands have in the earth, little studies until now made focus on those microbial communities. In spite of as we know, the soil microbial communities are involved in essential ecosystem services like climate regulation, soil formation, nutrient cycling, and also provide us of essential genetic resources that after that are used by the pharmaceutical industry, for example. For that reason, studies focus on understanding those more microbial communities are still essential to design strategies for their preservation, because not everything can be preserved with the techniques that currently have, and also are important because we want to exploit the biotechnological potential of they have the potential to present. In an attempt to improve our knowledge of those communities, we started to work with the University of Almeria to advance in our understanding on the biogeochemical processes happening in the Tabernas Desert in Almeria, Spain, and also as a previous step to unlock the untapped biotechnological resources held in drylands. What we did, this was a quite simple study. Now it has progressed a lot and is quite complex, but what I'm going to present today is a sampling that we carry out in the Tabernas Desert in the experimental site El Cautivo. We carry out a sampling which we collected a type of biocrust based on cyanobacteria. We collected two types of biocrust, incipient cyanobacteria and mature cyanobacteria biocrust. And we follow a metagenomic analysis. That means we extracted the total content of DNA and to explore not only taxonomy but also the metabolism. And we carry out different bioinformatic analysis in order to reconstruct the metabolism, the potential metabolism that those communities present regarding the biogeochemical cycles. We also carry out physical-chemical soil analysis. As we don't have so much time, I'm going to enter on how we analyze those data because it was kind of complex. I'm going to directly to highlight some of the insights. For example, regarding taxonomy, here's not very clear, but initially we pretended to find differences between incipient and mature cyanobacteria, but we couldn't. We can see that in mature the variability regarding alpha diversity is less, but we couldn't find significant differences. The same happened when we analyzed the beta diversity. We can see that, okay, mature, they look like more similar, but the same, we couldn't find any pattern. We're not really sure about why. Perhaps was because we use identical habitats and identical physicochemical parameters, because the physicochemical parameters are the drivers in ecology, the main drivers. But possibly we also have some experimental design limitations regarding the replicates, and also the algorithm that we use to assign the genes. Going directly to the data, and then we decided to analyze or to group the data as a unique group in order to see what is happening there. Regarding taxonomy, as we expected, we found that the minor groups were in the phylum of actinobacteria and proteobacteria. This is really common in arid habitats. There is always a dominance of actinobacteria and proteobacteria. In this case, it was also followed by bacillobacteria and ascomycota, as we expected. The presence of actinobacteria is always justified because they are really frequent because of the metabolism in poor habitats. In the case of proteobacteria, in biograss is really common because, as I mentioned, the biograss presents a primary productivity, and that biomass, that carbon organic matter, leaches to the lower layers of the soil and is taken by the proteobacteria that make a really fast carbon mineralization. When we observe the taxonomy at the genus level, we observe that the same dominant groups belong to actinobacteria. For example, we observe the genera Connexibacter, Rubobacter, Streptomyces, other actinobacteria like Mycobacterium. Some of the groups were also common in other arid habitats, but it was curious to find a dominant group, the Connexibacter as a dominant group. Connexibacter is a group that appears frequently in arid habitats, but not as a dominant. That was a surprise that we found in the Tabernas Desert. When we started a functional level, we found exactly the same. We were unable to differentiate if there were at metabolical level any difference between incipient and consolidated cyanobacteria biocast. When we made the metabolic reconstruction, filtering by metabolic pathway, we were exactly the same. We were able to find significant differences, but applying a random forest analysis, we were able to see some tendency in some minor groups, but we couldn't correlate those differences with differences in the metabolism of any specific metabolism associated to that group, to those groups. Focusing on some of the insights that we found regarding metabolism when we make the metabolic reconstruction of the minor groups, we observed that, for example, regarding carbon cycling, we got a very rich pool of extreme enzymes. In these minor groups, that in the carbon cycling was Caulobacter, Rosei-Flexus, Rubobacter, and Connexibacter. This group belongs to actinobacteria. Rosei-Flexus belongs to chloroflexi, to the phylum of chloroflexi. This is a photosynthetic group that also makes sense that is a dominant in the carbon cycling. The others presenting, as you can see here, a very rich pool of extreme enzymes that actually can be observed like a synchronous growth, because as you can see, depending on the group, they present different stages in the carbon degradation. That denotes a coordination in the macrobial community, but also is a source of biotechnological tools, because those enzymes that we can see in those minor groups can be used in industry because they potentially present unique properties. Exploring, for example, the fatty acid metabolism was also a surprise to find that those myogroups, Caulobacter and Urobacter and Connexibacter, presented a really high number of genes involved in the synthesis of natural polyesters, natural bioplastics, presenting this key enzyme. This enzyme is currently well studied in the genus Bacillus, but was never described in this that we got as a dominant, which is also really nice because obviously able to find isolates presenting those enzymes will be really useful for industry, and we need to preserve them. For example, regarding respiration, we got also a high number of different respiratory mechanisms, the usual ones like glycolysis, carboxylic acid cycle, and oxidative phosphorylation, but also the myogroups presenting the end-Rudolph pathways and other branches in the glycosylate cycle, telling us that they are successful survivals, that they adapted themselves to survive under those conditions, and possibly they can be the future colonizers. I mean, they will survive during the climatic change. What else? For example, in the carbon dioxide fixation, we expected to find a majority of orphan Cummins breeds, the metagenomic genes, coming from photosynthetic organisms, cyanobacteria, but was a surprise to find that most of them came from Caulobacterium, Urobacter, and Connexibacter again. Actinobacteria that was not identified until now, those mechanisms and the possibility of carbon fixation. That makes us to hypothesize that perhaps the arid soil can be considered a potential carbon sink, because if those groups are dominant, we didn't know until now that they have the potential to fix carbon. Perhaps we are leaving escape a possibility to use deserts as a carbon sinks, and also the possibility to use those strains as in soil restoration to improve the organic carbon in soils. Regarding potassium cycling, we got something different. We got that again, Urobacter was here as a dominant group, also appear nostoc, which is a cyanobacteria. In this case, most of the reads were coming from potassium homeostasis, but was curious that Urobacter, one of the dominant group, instead of presenting the potassium uptake system, the usual potassium uptake system that the bacteria usually use, which is the TLK, appeared this, which is hardly found in bacteria. Hardly found in bacteria, for the point of view of efficiency, is equally efficiency, but this is more efficient under acidic conditions. Then we can see here another mechanism of adaptation to those harsh conditions. Apart from that, those strains, including nostoc, appear as second mechanism able to uptake potassium when the potassium is a low concentration, which is also another mechanism that is telling us that it's well adapted to those conditions. Biotechnological potential of that, the use of those strains as a silicate solubilization microorganism, which is something really important in agriculture in drylands, as an alternative to synthetic fertilizers. Yeah. Okay, it's just one. Just to finish, I would like to say something about that. This is a very brief, because we make a really full metabolic reconstruction of all the dominant groups. For example, in the iron cycling, we found something really curious because we expected to find different mechanisms to bind iron in the dominant groups. But what we found is that the dominant groups didn't present those bound mechanisms. They present mechanisms to catch siderophores, which is a mechanism used in plants but also in bacteria that bind the ferric ion with a high affinity. What's happening here is that the dominant groups presented the capacity those transported to catch those siderophores, but not the capacity to produce them. Then here there was Pseudomonas, which is producing public goods. We can see here a coordination, a synchronous growth in the community. Then we saw here that there is a kind of specialization in which the group of cyanobacteria is also producing, is having an advantage, an ecological advantage, but also is possibly is leading the evolutionary story of that microbial community. And just to finish some conclusions, just to say that microbial bacterial community show a rich and redundant metabolic pool with the potential to drive carbon, nitrogen. We didn't say anything about nitrogen, but we explored nitrogen, phosphorus, sulfur, iron, and potassium cycles in drylands. And that functional redundancy is related to the correct functioning of the soil biochemical cycles, and that it's also possible to see some specialization, a type of trophic coordination or syntrophic growth. And also we observe some successful adaptation, some mechanisms really specific that were only found in the Tabernas Desert, possibly exist in other, but it was not studied until now. And yeah, the next purpose of our group, that would be the isolation of those major groups, because we need to preserve them, because they are really useful. We think that they are really useful for industry. Yes, to finish, thanks to my group in IFAPA and to our collaborators in the University of Almeria. Thank you so much.
Thank you, Dr. Montero. We are running out of time, but we might have one question or two. I actually have a question. So I was wondering if you had an issue with the taxonomic assignment of the microbes, and if you think these have influenced somehow a bit the results. I mean, it's something that is normal for any type of study using the barcoding data.
Yeah, that's true.
So.
Yeah, depending on the algorithm that you use, you can have a different assignment. And we have to take this result carefully because we can have different surprises. In the case of Connexibacter, was a surprise because actually, yes, the first time it appeared that dominant group in these kind of soils. And then in that case, we made different check-ins with different genes to confirm that was Connexibacter, and actually was Connexibacter. The thing is that there are not many species described in Connexibacter, there are only 5. And that means that it's really difficult to isolate them. But obviously there is a really high potential in them, and we have to, hopefully we'll get it. Yeah.
Thank you, Dr. Montero. We'll move to the next last speaker of the session, Dr. Antonio Pérez Luque, from the Estación Experimental del Zairin, who is giving a talk about tracking livestock movements to aid in the environmental management of the territory. Case studies from some HAL project in Andalusian.
Okay, thank you. Good afternoon. I want to show you some of the results of our code package within the code project. The extensive lactose offers different ecosystem services, but also can cause different ecological and socio-ecological impacts, particularly in semi-arid regions. This water management is important so that the territory can benefit from them and does not generate socio-economic and environmental harm. Recently, it has been highlighted that animals' mobility is an important factor to consider in the assessment and reserve of potential impact of grazing of natural systems. Within the Sunhal project, in the work package 7, we are improving the sustainability of the Mediterranean forest and silvopastoral ecosystem under climate change. Specifically, we are working in 2 sub-projects focused on analyzing the role of traditional silvopastoral in ecosystem biodiversity and the prevention of forest fires in the rural area of Andalusia. Our group from the experimental station of CSIC, which belongs to the CSIC, we are working on analyzing the movement of the animals, of the livestock. And in this work, we are present data up to show this data. The app is an open source application generated for managing and visualization the structure of data in the movement. You can choose different shapers and choose different temporal length, and the app shows you the station of the data, the GPS data. Then the aim of the app is to assist natural resource managers, scientists, or also farmers, livestock farmers, in analyzing and planning actions related to livestock and its interaction with biodiversity, fire prevention, and other factors. In the first step, we focus on identifying the potential users and also the potential question to respond with this. We consider 3 potential users: the scientists, manager, and farmer citizens. Different potential questions. For instance, the scientists would like to ask answers how is the grazing intensity and its effect on plant communities. The managers also are interested in what is the extent of the grazing intensity and how does this affect to the biodiversity, or can we use the livestock farming in the prevention of wildfires? And also the farmers may be interested in where do the livestock area typically occur, or how is the temporal pattern of the livestock farming. Of course, all these potential questions may be of the interest for each one of the potential users. We test this application in 4 locations belong to different natural protected areas of Andalusia, trying to cover a high ecological value, from the Cabo de Gata Natural Park to Sierra Nevada and Sierra National Park, and also the Lake of the Sierra Filares. All these study sites is located in the southern part of Spain. We selected 14 herds composed by different types, goats, or sheep, or a mixture of them. The herd size ranges from 3,300 to 1,500 herds. We set 94 GPS devices with different technologies to capture the position of the animals. We use Sigfox or GCN technologies, also satellite device technologies, and also data objects. The use of the different technologies is to try to cover the areas below network. The workflow of app is formed by, in the first step, we collected the data that the GPS device sent us. We use a semi-automatic workflow to capture this data. Then we use different script in R or Python to integrate the data in a SQL database. Then we perform several quality control quality assessment related to temporal gaps or to files on the GPS. And then we integrate the data into a spatial layer that the user can be used to perform different data analysis. And the next step is to integrate our data in different repositories. We are now, I will show you some potential showcase. And the first one is the uses the livestock as the preventive livestock grazing. In Andalusia, there is a program. The RACA program is called the Andalusian Network of Grazed Full Bred. It's a payment scheme that rewards the shipper for service of biomass control and full bred maintenance of fully forest land at high rates of wildfires. The rewards is depending on the size of the area, the success of the work, and the difficulty of the effort. To pay to the shippers, the technician perform an evaluation in the fire of how the livestock is doing the work. We think that with our app, we can add to the technician to give us a spatio-temporal approach to improve the evaluation of the services provided by the livestock. For instance, you can see here in the left different firebreaks with the blue points, the blue dots. Sorry, is the position of in this case the sheep along the firebreak. In the app, you can select the temporal range and you can obtain different types of kernel density maps or so on. We also can improve this assessment if we combine with the different assessment of vegetation using satellite data. For instance, you can use NDVI data from Sentinel to compare the vegetation status of the grazing firegrass or no grazing firegrass. Combining these two kind of data, you can improve the evaluation of the work done by the livestock. Another potential case use was the evaluation of the several plant communities. For instance, the Antivinon chidemi is a critical endangered species of the southern part of Almeria. One of the main traits of this species is the pressures by Guadalquivir. And in this map, you can see in blue the known distribution of this plant species. And in the red color is in the distribution of the goat, or the goat lift, in this area. As you can see in the right part, you can explore more in detail what is the population of this plant species, but it's most affected by the livestock. Well, the next step of the application, first we need to generate a stable version of the app that can be used directly by managers, scientists, and lecture farmers. Yes, it is because actually the app is locally in all laptops. We want to integrate in a virtual research environment, for instance, or so on, and we need to generate a stable application that can be used by different users. The next step, another one step is to compute and show different information of interest derived from the GPS position. For instance, temporal pattern of movements, maybe movement paths, etc. Then we would like to integrate the data into repository for instance, MoveFan or GB or so on. This one. Thank you.
Any question from the audience? Everyone needs caffeine, okay. And I was wondering if it was difficult to involve farmers in the project, because I imagine it was.
It was very difficult. We only get 14 in four areas. There are some other, but if you go to the shepherds and say, hey, would you like to use the GPS? Someone is no. It's very difficult.
But do you think it's also related to the fact that they cannot go to some areas and try to, or it's just they're just not confident?
I think it's both.
Okay, thank you, Dr. Perez. There is another, yes,
Well,
yes.
Just for curiosity, I wonder if you have considered also to include in the system, there are several initiatives of open Internet of Things networks. So people not only provide, they can provide, the infrastructure, and in some areas in Europe are very well covered. In Spain there are some areas, but even with part of your own budget, you can create these nodes, especially in the shadow areas. But it's just
In some areas, we try to install several devices of Sigfox, but it's very expensive to cover.
Yeah, but Sigfox is a commercial one.
Yeah.
I was wondering, there is this open initiative, and it's very low cost. And I know in some areas in Spain it's already covered, and in some areas you can use low cost systems, to cover. Okay, we can take.
Okay,
thank you.
Thank you again, Dr. Perez, and we close the session this way. So thank you again to all presenters of this session, and let's go get caffeinated.